Hello, everyone. Today we're going to see how we can use the properties in a parallelogram to prove things. So I'm going to start out with number one. So when I'm doing number one, the only given I have is that ABCD is a parallelogram. You'll often see this little symbol for parallelogram. So now knowing that, I want to prove that triangle ABC, so triangle ABC is congruent to triangle CDA. So knowing that ABCD is a parallelogram tells me a couple of things. First of all, it tells me that BC is congruent to AD and that AB is congruent to CD. And the reason for that is opposite sides of and I abbreviate parallelogram as the parallel symbol, ogram, are congruent. Now I have a couple of different options to continue this proof. I can either use the reflexive property on AC, or I can use the property that angle B is congruent to angle D because opposite angles of a parallelogram are congruent. And depending on which one of those choices you used is what method, but a triangle ABC in my situation is congruent to triangle CDA by side, angle, side. And that's how I can use the properties of the parallelogram in other proofs. So I would like you to pause and try number two, and then come back and compare your answers with mine. Okay, so I'm not completely done, but I wanted to pick up here. So I started out with saying that DC is congruent to AB and AD is congruent to BC because opposite sides of a parallelogram are congruent. And then because I really want EA and FC, because I'm trying to get these little yellow triangles, I did subtraction because I knew DF was congruent to EB. So I did DF minus DC equals EB minus AB, subtraction, and that gave me EF is congruent to CF. Now I need to try to get an angle or the other side. I can't see any way to get the other side, but I do know that angle DAB is congruent to angle BCD because opposite angles of a parallelogram are congruent. So that means that is congruent to that. Now I also know that angle DAB and angle DAE are supplementary, and that angle BCD and angle BCF are supplementary. And that's because linear pairs are supplementary. They make a straight line. And then knowing that, I can say that angle EAB or EAD is congruent to angle BCF. Supplements of congruent angles are congruent. And then finally, I have my triangles by side, angle, side. And I'm running out of room down here. So there's that proof. So next, I want you to pause and I want you to try number three and then come back and check against mine. Okay, so for my proof, I started out by saying that AD and BC are parallel because they're opposite sides of a parallelogram, so they are parallel. And then I looked at line FDEC, and I realized that I had corresponding angles. So that means that FDA is congruent to ECB because parallel lines imply that corresponding angles are congruent. I then knew that I had perpendicular lines, so angle F is right, and angle BEC is right, definition of perpendicular. Therefore, F is congruent to BEC. AD is congruent to BC, opposite sides of parallelogram congruent, and FDA is congruent to triangle ECB by angle side. One more proof for today, and then we are done. So please pause and try this proof and come back and check it. Okay, so for this proof, I started out with angle A is congruent to angle C. Opposite angles in a parallelogram are congruent. I then said that AD is congruent to BC. Opposite sides in a triangle are congruent. I also said that AB is congruent to DF, or not DF, DC, because opposite sides in a parallelogram are congruent. And that helped me then because I know that F is the midpoint of DC and E is the midpoint of AB that's given. So I said that AE is half of AB and CF is half of CD. And then I could use that theorem we learned a long time ago that says AE has to be congruent to CF because halves of equal quantities are equal. And therefore I have my triangles by side, angle, side. If you have any questions, please bring them to class tomorrow.